Okay, so today I'm covering matrix inverses, and I have an existing video talking about this, but I feel like the video covers a lot and doesn't really, it's trying to smush a whole section in one video. So I'm going to just focus on how to find the inverse of a matrix in this video. The second half of this section is actually using inverses to solve. And that is just basically doing matrix multiplication after that. So the hard part is actually finding the inverse. So that's what I'm focusing on here. So when we think about what the inverse of a matrix is, let's just think about the equation AX equals B. Because when we have equations we're solving with matrices, that's basically the form that we're in. So when we're solving that just outside of matrices, but just regularly solving for X, you're dividing both sides by A. And that's actually the same thing as multiplying by the reciprocal 1 over A. So I'm going to just write that here. So you're multiplying both sides of your equation by 1 over A. And that would just cancel out A. We normally write it as division. We don't normally write 1 over A. But that 1 over A, if we go back to our rules of exponents, that is equivalent to A to the negative 1. If you think of A as being, a variable, that a negative 1 exponent is the reciprocal of whatever your variable is. So we can rewrite the 1 over A as A to the negative 1. So if A to the negative 1 times A times X equals B times A to the negative 1. And actually, I'm going to put the A to the negative 1 in the same order here. Now, the 1 over A times A, that just cancels out. So A to the negative 1 times A, it cancels out because if you add those exponents, it gets to 0. So it would just be a 1. So you just end up with X on the left. But on the right, we end up with this A to the negative 1 times B. And so when we're solving equations for X, we go through this process. We don't really think about what it looks algebraically, that you have A to the negative 1 times B. But that's actually really important because that's what we look at when we're looking at it in regards to matrices, when we actually have matrices here. Which way would you normally want to write this? 1 over A or A to the negative 1? So when you're just solving for X, a normal linear equation, 1 over A is fine. But when we're doing matrices, it's specifically written as A to the negative 1. Because that is what we mean by having the inverse. So we use capital letters when we're referring to matrices. And so instead of solving with the lowercase AX equals B, you've got all capital letters, AX equals B. And you're basically doing that process, which gets you X equals A to the negative 1 times B. And that's how you can solve and figure out what your unknowns are by solving that matrix equation. So instead of doing your row reduction and your Gaussian elimination stuff, you can instead do this method. And that A to the negative 1 is what we call the inverse matrix. So it's specifically written in that notation, A to the negative 1. So you don't write that as 1 over A because when we have matrices, it's not equal to 1 over A. So the negative 1 exponent, when you have just regular variables or a number, is basically the reciprocal, but it doesn't work that way with matrices because matrices are more than one number. You've got a lot of things here. So it's not actually the reciprocal, so we use the A to the negative 1. And the inverse is not just taking the reciprocal of all the numbers in the matrix. It doesn't work that way, unfortunately. So we're going to have this new notation here, A to the negative 1, indicating that we have the inverse. And just one thing to note is that the order of multiplication here does matter. So unlike when we just have regular numbers and we're multiplying the order of multiplication is commutative. You can multiply the numbers in different orders. 2 times 4 and 4 times 2 gets you the same answer. For matrices, it doesn't work that way. So you have to do it in the order a to the negative 1 times b. It must be in that order. If you try to do it in another order, it's not going to work. So you have to do it in a specific order. And then if you've got your a times your inverse of a, normally when we work with numbers, if you multiply 2 times 1 over 2, you get 1. But with matrices, instead you get the identity matrix where you have 1 in the diagonal and 0 elsewhere. So you don't just get 1 when you multiply these, you get the identity matrix. So working with matrices are similar to working with regular numbers, but there are some key differences. The fact that it's not actually the reciprocal, the fact that the order matters when you multiply, and things don't just cancel out and get you a single number, you get the identity matrix. So that the inverse is used for solving, and this is where it shows up, is when you're actually trying to solve like normal algebra and you end up with this equation x equals a inverse times b. So we know that we can use an inverse to solve. But the question is, well, how do you find that inverse? Because we know it's not the reciprocal. I told you that it's not just 1 over whatever the numbers are. So how do you actually kind of get to the inverse? And then, does everything have an inverse? So first, let's address, does every matrix have the inverse? The answer is no. So what this means is that you cannot solve every single matrix equation this way, because not every matrix will have an inverse. So while you can always do Gaussian elimination or Gauss-Jordan elimination, you can't always solve this using this way. So in order for a matrix to have an inverse, it must be square, so the same number of rows and columns, and the determinant of the matrix cannot equal 0, and that's actually covered in section 8.4. So there are certain types of matrices that have inverses, and if there's an inverse, then you can use this method to solve, but it doesn't always work, which is why we have our other methods. So if a method or a matrix has an inverse, we call it invertible. If it does not have an inverse, it's called singular. So just before you go on the homework and say, okay, I'm going to use this method for every single problem on the homework, just as an FYI, it may or may not work because you don't know if the matrices have an inverse. You'd have to try to find the inverse first. And then if it doesn't have an inverse, then you would have to find another method. So just, don't assume that this method is going to work on every problem. So let's say you've determined that the matrix is invertible. It does have an inverse, so you can solve using this method. Well, then how do you actually find the inverse? So there are basically two methods. So the first is to set up a matrix equation, a times x equals I, because a times whatever the inverse is will give you the identity matrix, and you're solving for the inverse, which is your unknown x. You multiply those together, and the x is going to be a matrix of variables, and this is going to give you two systems of equations, and then you solve using our methods from last week. So you can solve the two systems with elimination or substitution, or you can then do in row reduce, do like Gaussian elimination on those two systems. But you have to solve then those two systems with some sort of technique. Method 2 is to create a new matrix where you have your matrix A, and then to the right of it, you have the identity matrix. And then you do Gaussian elimination. You want Gauss-Jordan elimination because you want the row reduced echelon form. And that will give you the identity in front, and then whatever is after the identity matrix is your inverse. So there's two methods here. Neither one of them are fast, I would say. They're not necessarily fast methods. And there are some shortcuts, but I don't think they're even that much quicker. There's a shortcut for 2x2s, which I tend to always mess up. So I don't like using the shortcut because I get it wrong. I mess up my signs. I put numbers in the wrong spot. I just tend to make a mistake, which then means it takes just as long as doing one of these other methods. And then the shortcuts for like things that are larger than a 2x2 are just as long, maybe even longer. It depends on what other things you've done to the matrix. So I put shortcuts in quotation marks because I don't know if they're necessarily shortcuts. The bottom line is finding the inverse of the matrix is not fun and not, it's tedious. It's very easy to make mistakes. And so once you kind of start applying linear algebra and these topics from this week to things, other parts of math, technology is the way to go if you're going to solve this way, because it's just doing it by hand is not easy. So mentioning technology. So I mentioned that Octave is free. I recommend Octave because I know for those going into engineering, it's mentioned in your future classes. So it's good to kind of start playing around with it now so that you can use it in your future classes, because I know that there will be matrices you'll have to solve systems of equations, that sort of thing. It's completely free. You can do it online, you can download it, whatever you want. And there are two ways that you can use Octave to check your work. So the first way is to literally type in your matrix and then use the exponent to the -1 notation, and it will give you your answer for the inverse. So then that's an easy way to check, did you get the inverse correctly? The second way is by actually doing method 2. So you create your matrix, then you create your identity matrix. So that's what this I2 means. So it's a special command that creates an identity matrix that is 2x2. So that's why you put 2. You want how many rows or columns. And so I save that as I. You can see the result. It's the identity. And then you row reduce it. So you do Gauss-Jordan elimination, which is RREF. And this is the creating your matrix of the given matrix and then the I attached to it. And then it will row reduce it and then give you your answer. And then this is your inverse, which for this matrix would be B to the -1 because the matrix was B. So there are two ways that you can check your answers. Either one works, it's kind of up to which one you want to do. If you're doing it by hand, you might want to check doing the row reduction just to make sure you row reduce correctly, whatever, whichever way you want to check it. But just so you have that, Desmos also has a matrix calculator that you can use to check as well. But I'm just focusing on Octave because I do know for quite a few of you people, it will be showing up. So are there any questions before I actually start doing examples and showing you the whole, actually going through the process here?
Hey, Stephanie.
Yeah.
I actually have issues a lot of times just doing the Gaussian-Jordan elimination. I know that's probably not a popular thing for me to say right now, but oftentimes I get with fractions and all that stuff, I get the wrong answer, and then I wind up with my identity being wrong.
Mm-hmm.
So I'm just practicing, trying to get better at it, but it's rough at times.
Yes. And that is very common. I messed that up as well. Anything with matrices that I do by hand, I tend to make mistakes. And I will actually later on, I have some images of finding the inverse of a 3x3 with the shortcut. and I have a whole bunch of white out on it because I messed up. So it does happen. If you have things with fractions, I recommend using technology to just do the multiplication of fractions, add fractions, just to help eliminate some issues there. But yeah, it's very common. This is why having technology to check your work is helpful, because then at least you know you might have messed up somewhere. But it does take time to kind of check where you messed up, and organizing your work is really important to help you double check. So hopefully when I go through my examples here and I show you how I organize it and try to keep it clear, hopefully that will help you as well, so that it kind of helps you find where you might have made errors. Because if you're not organizing or very clearly writing down what you're doing, it's a lot harder to check your work and find your errors. So hopefully what you'll see will help with that. Otherwise, I mean, it happens. And that's why technology is so important for this, because it's just so much easier to make a mistake when you're doing these things by hand. So,
Okay, thanks.
yep, you're welcome. So for this first example, I'm going to show you method 1 to find the inverse. This is a 2 by 2 matrix. So we've got 1, 2, 3, and 7. So for method 1, you are setting up AX equals I. So what this means is that we have the matrix A, which is 1, 2, 3, and 7. And then we're going to have a matrix of the same size. And we're going to have 4 variables here. So our book uses x1, x11, x12, x21, and x22, which I think can be very confusing because it's like you've got all these subscripts. So I'm going to just say we've got A, B, and then X and Y. I mean, you could do A, B, C, and D if you want. Or you can do X, Y, Z and something else. I don't know. You can use whatever ones you want. It's just the way that the book has it labeled. I just find it really, really confusing. You know what? Let's just do A, B, C, D. Let's just go from the alphabet. So then you're going to set this equal to the identity of the same size, where it's going to be 1 in the diagonal and then 0 elsewhere. And this unknown matrix, that's A, B, C, D, that's going to be our inverse that we're trying to find. So your next step is to actually multiply these two matrices, A times X. And so matrix multiplication is one place where people tend to make mistakes. So I like to highlight, which it's harder to do it when you're on paper, because if you're highlighting, you can't unhighlight, but it's really fantastic if you're doing things on a computer where you can kind of erase your highlights. So it's always your row times the column. And that gets you your first entry here. So we're going to get a matrix that looks really large and complicated. And then we're going to kind of combine it into, we're going to like piece it apart. So I'm going to try to color code these things. And so row times column gets put kind of where the top left is for this first row, first column. So it's going to be 1 times A, which is just A, plus 2 times C. I don't know why my pen's being so weird here. No, it won't erase. Let's try this again. Here we go. And so that's the first kind of multiplication there. So, whoops. Trying to erase my highlighters is not from the best. So then you're going to take same row, but now you're going to multiply by the next column. And that will get you your next location. So it's going to be 1 times B plus 2 times D. And so that's going to give us the first row. And now we need to do the second row. So I'm going to highlight second row, 3 and 7, and then you go back to the first column. So it's going to be 3 times A, and then 7 times C. And that gets written in, basically, it's going to match with this lower left corner. And then you're going to move to the second column, but you're going to stay with that second row. So, and that's going to be going into the bottom right. So it's going to be 3 times B, and then 7 times D. And then we have now multiplied that first matrix, A times X. And it looks kind of messy because we've got these variables inside this matrix, because we can't actually add them. They're not like terms. But we do our multiplication here. Your next step is to then leave the matrix here and to write these as systems of equations. So you're kind of now exiting matrix world. And you're going to get 2 systems. And you're going to match the first column in the left matrix with the first column in the right matrix, and then the second column in the first matrix with the second column in the right matrix. And that's going to get you your 2 systems. So each column gets you one of your systems. So we're going to have A plus 2C equals 1, and 3A plus 7C equals 0. And then you get a second system, B plus 2D equals 0, and 3B plus 7D equals 1. So it's like you're matching the columns with the matching column on the other side of the equal, because if they're equal, then yes, those columns should match. And each entry should match with the entry on the other side. So any questions so far?
Does it matter which 2 we group with the systems? Could we have used rows instead of columns, or do we have to use columns?
You're going to want to do columns, because if you match the rows, then you're going to still have something with 4 variables.
Oh.
So we want to make sure that we're matching the columns so that you have only 2 variables in there.
I guess in this case, that would be what we'd want. But if it was a different matrix, maybe we'd want to do something else.
It's always, when you're doing this method, you're always going to end up with the columns having the matching variables.
Okay.
Yeah. That's a good question. Are there other questions? Okay, so now what you have is you've got these two systems, and you can solve them with elimination. You can solve them with graphing. You can solve them with substitution. You can put each system into an equation and do Gaussian elimination or Gauss-Jordan elimination. You have lots of choices to solve these. The key is just solve these things, basically. So I'm actually going to do substitution on both of these because I noticed just for both of these, the first row can easily, like the first system, I can rewrite the first equation in terms of A. I can solve for A there. And then the second one I can solve for B, and then I can substitute them in. So I'm going to just solve these with substitution, but you could solve these whichever method you prefer. And so I actually encourage you to maybe work your method while I'm doing the substitution method, and then we can compare, make sure we're getting the right numbers. Because if we get different numbers for A, B, C, and D, then, there's a mistake somewhere. So it's a good way to check your work against mine, see if you can get the same number. You can choose whichever method you want. If you want to practice the Gauss Jordan elimination or Gaussian elimination, you can do so. So I'm going to start by rewriting my systems here. And the first one I'm going to solve for A. So that would be A equals 1 minus 2C. And then the second equation is 3A plus 7C equals 0. And then my second system, I'm going to solve for B, that first equation. And so that would be B equals negative 2D. And then the second equation in there is 3B plus 7D equals 1. So I'm going to do this with substitution. You can choose whatever method you want. If you're doing this on your own, you can type your answers in the chat and we can see, where do we end up? Are we with the same answers? So I'm going to start with the first system here and plug in for A. So I get 3 times 1 minus 2C plus 7C equals 0, and then I'm going to distribute. So I get 3 minus 6C plus 7C equals 0. 3 plus C equals 0. C equals negative 3. And then A equals 1 minus 2 times negative 3. 1 plus 3 equals 4. Then second system, I'm going to solve t equals 1 and negative 2. So I have 3 answers. I have, if I go in order A, B, C, D, so A is 4, B is negative 2, C is negative 3, and D is equal to 1. And these are the numbers for my inverse matrix. And we're going to go A, B, C, D. So A is 4, then B is negative 2, C is 3, and D is 1. So has anyone tried to solve, can anyone verify? I mean, I feel like I got whole numbers, which is a good sign because these problems are designed to get whole numbers. So if I had made a mistake and got like a decimal or something, that probably meant I messed up somewhere. Has anyone worked the solving of their systems here to verify that this is the answer that they got? Okay, well, if nobody has verified, we can use Octave to verify. So to use Octave, I need to plug in the original matrix here. Okay. Okay, you prefer substitution, so you're following along. That is fine. So if you're going to check your answer with Octave, you entered it row by row and you put a semicolon after each row. So A is equal to, and then I have my bracket, 1 space 2 semicolon, 3 space 7, and then you close your bracket. So that's how you enter in the matrix in Octave. So it's row by row with a semicolon at the end of each row and then a space between each entry. And then you can verify when you hit enter that it looks like the same matrix you have here. So to verify my inverse, I'm going to just use the inverse command, basically type A, and then I use the caret to get the exponent, -1. We get 7, -2, -3, 1, which is not what I got. So this is why we check our work, because I might have made a math error somewhere. That's why
I got a 7, -3, -3, 1.
Okay, you're almost there because the correct.
That's from left. Should I read that left to right? So it'd be in the position A, be 7, -3B, -3C, and then 1D.
Okay, yeah. So we always read it from left to right, the top, and then the bottom. Okay, so you got closer than I did. I have my first number, the 4, messed up. You have your second number, the the -2. You got a -3. And John is asking, is there a space between the semicolon? You don't have to have a space there. You can not put the space, and that will be fine.
Wait a minute. Spaces in between the other two numbers, right?
You have to have a space between the two numbers.
Yeah.
So this is why we check our work, because doing, it's very easy to make a mistake. And so then the question is, well, clearly I got
-2. I see where I made my mistake.
I see where I made my mistake too, actually, now that I'm looking at this. I said that -2 times -3 is 3, which now that I'm looking at my work, that's clearly not right. So this is why I'm showing you guys technology, because it's so easy. You're dealing with all these numbers. So that should be +6, which then gives me 7. And so there. I get the correct answer. So yes, you are going to want to check your work, because it's so easy to make a mistake. You're looking at so many numbers that, and it's just inevitable. And so always check your work. And then if you've organized it kind of the way that I have, you can start working backwards and kind of see, where did I potentially make my mistake? Are there any questions? Okay. Well, let's move on to method 2. So, and I'm specifically doing this on a 3x3 because I know those are where people struggle. It's with the larger ones. Like, you might be fine to do it on a 2x2, but you usually struggle when it's a 3x3. So that's why I picked this one to do method 2. So method 2, our first step is to set up a matrix of A, and then the identity. So we're going to end up with a very long matrix. So first I just copy my A matrix. And then you're basically kind of putting the identity after it. And so you end up with 3 rows and 6 columns. So it's going to be long, and being organized is very, very important here. So I'm just adding myself some extra slides just so that I have enough room for everything that I'm about to do. So step 2 is we need to do Gauss-Jordan elimination, where we're getting the row reduced echelon form. So if you're getting stuck on Gaussian elimination, Gauss-Jordan is the same thing, just with extra steps. So what I do here is going to help you with Gaussian elimination, because it's basically you start off the same way. And I'm just going to try to keep this as organized as possible. So the goal of Gauss-Jordan elimination is to have the identity matrix in the beginning. So I'm going to just highlight that we already have one number that is where we want it. That lower left corner being 0 is good because we want to have a 0 there. Now, what I usually do when I'm doing Gauss-Jordan elimination is I work column by column. So I try to get my zeros in the first column first, and then I get my 1. And then I move on to the second column and get my zeros there, and then my 1. And then I move on to the third column and get my zeros, and then my 1. So I do it in a very organized manner to try to, it's like that way you don't get lost. It's like, this is my method. This is what I do. So I always start with trying to get the 0 in the bottom left corner, which we've already got. Then the next thing that I want to do is get a 0 above that. So I'm going to just kind of highlight, I want to get that -1 to be a 0. So that's my goal. And I can do that by multiplying that second row by 2 and then adding the first row to it, because that will cancel out that first spot. So I want to, and this is kind of how I write it. So I want to multiply, actually, it doesn't really matter where I do it, but I've got row 1, and then I want to multiply row 2 by 2, and then I'm going to add those together, and I'm going to replace it with row 2. So I'm writing down what I'm doing and then where it's going to go. So row 1, we're not doing anything with. So I'm just going to write my row 1, and yes, it's going to be very long. So I just kind of write the numbers, ignore, all the brackets and stuff, because we're kind of doing this outside of the matrix. And now I'm going to multiply row 2 by 2, and I'm going to write that result. So I don't try to do this in my head, because if I try to multiply by row 2 and add row 1 all at once, I tend to make mistakes. So -1 times 2 is -2. 11 times 2 is 22. -7 times 2, we get -14. 0 times 2 is 0. 1 times 2, 0 times 2 is 0. And so always double check. Don't trust that I'm doing the math right. Don't think it through yourself and make sure that you're getting the same numbers, because it's so easy to make a mistake here. And now I'm going to add all of these numbers going down. So I get 0. I'm going to use my calculator for the next one just to make sure I'm do it right. This is one of those things that it's like you should, maybe it's almost better not to do it mentally because you might make a mistake. So when I add these, I get 0, 5, -3, 1, 2, and 0. So I'm going to write my matrix over again with these new numbers. And then I like to highlight the things that I have in the right places. So next step, we've got our zeros. The next thing we want to do is to get this top corner to be 1. So I need to divide row 1 by 2. Because I want to make that 1. And this is going to give us fractions. And this is where oops, I just dropped my calculator. This is where you want to have your calculator handy. Have a calculator that can do fractions because you will get fractions. It's inevitable. It's going to happen. There's really no way around it. So make sure I'm in my pen mode. I'm taking row 1 and I'm dividing it by 2. So instead of writing it as like you're multiplying by a fraction 1/2, I will just write it as divided by 2. So that gives me 1, -17 over 2, 11 over 2, 1 over 2, 0, 0. And I know I have my zeros here. And then I've got 5, -3, 1, 2, 0, 3, -2, 0, 0, 1. So doing these things by hand can take a lot of steps. So now I've got my 1, 0, 0 correct. My next goal is I want to get this 3 to be 0. To do that, I'm going to have to basically, I don't really want to deal with the first row because then I'm going to get a 1 in there. I have to do it with the second row. I basically have to multiply the second row by -3. Or I could do it by 3. And then the third row by like a 5 or a -5, depending on where you want to have those negatives. If you wanted, you could get the 5 to be a 1 first, but then that's going to create more fractions. And I'm trying to avoid creating more fractions as long as possible, just to make things easier here. So I'm going to so I'm going to do -3 times row 1, and then 5 times row 2. And that result, 5 times row 3, -3 times row 2. And then that's going to be stored in row 3. So I'll multiply that second row by -3. And then the third row by 5. And then I'm going to add them together. So I've got 0, 0, -1, -3, -6, and 5. So I'm going to write my new matrix. So the first row is untouched. Second row is untouched. Third row is now 0, 0, -1, -3, -6, 5. And so if we look at what we have correct so far, we've got our first column the way we want it. We have our 0 the way we want it. And we almost have that 1 in the diagonal, that lower right one correct, but we've got a negative. So we could kind of just make that a +1 right now. So I would just say then multiply row 3 by -1 so that we have that part correct as well. And that just changes all the signs. That's easy enough to do. And so we've got kind of our first column right and our last row correct there. And we need to we've got 4 more spots that we have to deal with here. So the next thing to do would be to take that 5 and we need to make that a 1. So we need to divide row 2 by 5. So that is going to be kind of the next step. So I'm taking row 2, I'm dividing it by 5. And my first row is staying the same. So it's a lot easier when you don't have to switch slides like I am. Okay, I know those are 0, 0, 1. So that's going to be a 1. -3 divided by 5. So that's a -3/5. 1 divided by 5 and 2 divided by 5. And then 3, 6, -5. So going back to my highlighter, I've got my first row or first column correct, most of my second column correct. And I've got my 1s, but I need to get 0s above all of my 1s. So we need to get that -17/2 to be a 0. So we're going to be multiplying, and this is where you're really going to need a calculator because this is going to get really, really gross. Or what we could try to do is eliminate, we could do this 2 ways. So we could multiply row 2 by 17/2 and then add that to row 1. And then we've got all these fractions. Or we can multiply row 1 by 2 and then row 2 by, let's see, -17 or -17 and then add them. But then we're going to end up with a 2 in the top left corner, and then we have to divide by 2 after we do that. So if you try to kind of get rid of your fractions before you do this, and then you'll have to divide it back out. So I usually just say I'm going to rely on my calculator for this fraction work. And so we're going to multiply our second row by 17/2, add that to row 1, and then that's going to be the new result for row 1. So I'm going to write this very carefully. So we're going to have our row 1. We're going to have 17/2 times row 2. And then whatever this result is going to be the new row 1. So I'm going to copy down my row 1. And now I'm going to divide or multiply by 17/2, and this is where I'm going to use my calculator. So I'm -3 fifths times 17 over 2. So it's negative 51 over 10. Then I have 1/5 times 17 over 2. 17 over 10. And I could just do all of these multiplications in my head, but I just want to make sure I don't make any mistakes. So then I get 17 over 5, and then we get a 0. And now I'm also going to use my calculator to do the addition here, because it will be faster than trying to get a common denominator. So definitely use your calculator here. So 1. Make sure you're typing it in your calculator wrong. I just make sure all your signs are correct. So I get 1, 0, 2/5, 11/5, 17/5, 0. And so my new matrix, 1, negative 17 over, nope, because I'm replacing row 1, 0, 2/5, 11/5, 17/5, 0, 0, 1, negative 3/5, 1/5, 2/5. I feel like I'm counting Dr. Seuss. 0, 0, 1, 3, 6, negative 5. So I'm going to highlight what we've got in the right spot so far. 1, 0, 0, 0, 1, 0, and then a 1. So we have to get a 0 above the 1 in the third column. So the 2/5 needs to be made a 0, and the negative 3/5 needs to be made a 0. Count chocolate from the cereal, yeah. I was just thinking 1/5 like sounds like 1 fish, 2 fish, 3, red fish, blue fish. So that's where I was like 1/5, 2/5. So I usually go with row 2 here. So I will multiply row 3 by 3/5, add it to row 2, and get row 2. So we don't have to do any more division here. So making sure I write down exactly what I'm doing so I can check work. I'm going to, my row 2 is going to stay the same. I'm going to take 3/5 of row 3. They're going to be opposite signs, so that's good. And then that's going to replace row 2. So row 2 is 0, 1, negative 3/5, 1/5, 2/5, 0, 0, 0. This is going to be 3/5. And then I'm going to double check my calculator when I'm multiplying here. 3 times 3/5. I know I can do that in my head, but you don't want to make any mistakes here. 9/5. 6 times 3/5. 18/5. And then negative 5 times 3/5. And that comes out to negative 3. So then I add 1. Whoops. Yeah, that's a 0. That's going to be 10. Goes to 2. 18, 19, 20 divided by 5 is 4. Negative 3. Stay on the previous slide for a second. Okay. Let me know when I can move back. Okay. Yeah, a lot of stuff to write down here. So I just got my new row 2. So my new matrix right now is 1, 0, 2 fifths, 11 fifths, 17 fifths, 0. Now this is my new row 2, so 0, 1, 0, 2, 4, -3, and 0, 0, 1, 3, 6, -5. So if we look at what we have correct, we have one more spot that we have to make a 0 here, and that's the 2 fifths. So 2 fifths needs to be made 0, and we're going to do that by multiplying row 3 by a -2 fifths. So we're going to have our row 1 -2 fifths times row 2, and then this is going to times row 3, and then this is going to be saved in row 1. So I'm going to copy down my row 1. And then I'm going to multiply my row 3 by -2 fifths. It's -6 fifths. 6 times -2 fifths. -12 fifths, and then -5 times a -2 fifths. That is +2. And then we're going to add those together. We got 1, 0, 0, 1, 1, 2. And that is our new row 1. So we're going to have to rewrite our matrix again with the new row 1. And so we get, I actually, I took a picture of my own screen so I can write this down. We got 1, 0, 0, 1, 1, 2, 0, 1, 0, 2, 4, -3, and 0, 0, 1, 3, 6, -5. And once you get that identity matrix to the left, you have finished your Gauss-Jordan elimination, and your inverse is the matrix to the right. So we did all of this just to find the inverse. This is not even solving. All we did was find the inverse. And so our inverse matrix is 1, 1, 2, 2, 4, -3, 3, 6, -5. And this would definitely be one that you would want to check with technology because of all these steps that we did. You know, it's a very long process. So now what's kind of nice about the inverse is that the inverse of the inverse will get you back to the original equation. So if I find the inverse of my inverse matrix, it will go back to what our original one was. But let's go back many, many slides to what the actual matrix we had here that we're looking for the inverse of. So A equals 2 space -17 space 11, and then a semicolon. Oh, and I forgot my matrix bracket. Let me put that in there. And then I don't have to have a space here. So I can just go straight to -1, space 11, -7, semicolon, and then 0, space 3, space -2, close your bracket. Okay. And just double check that you typed your matrix right, and then our inverse. 1, 2, 3, 1, 4, 6, 2, -3, -5. Okay, we didn't make any mistakes this time. Yay! You can see it checks out. All of the work was correct. So this is how you find an inverse. And for a 3x3, this process that I just did, it's not any quicker. I don't think it's not necessarily any quicker than doing the shortcut way. So is there a shortcut for a 3x3? Because you saw how long this process was. So step 1 is you have to find the determinant, which is something that you haven't seen yet until you go to the next section. And that's not necessarily something that's like really easy to do for a 3x3. Then you have to find what's called a cofactor matrix. And that is something in the reading, in the later reading, it talks about how to find cofactors. Then you find what is called the adjoint, which is basically the transpose of that, which you do learn about transposes. And then you do this calculation. So all of these things are in the reading that you could do for a 3x3. So I didn't do it for the matrix that we just did, though I wish I had. But I'm just going to show you if this other method, how much work it is. So I just had, you don't have to copy this down. I just want to show you that. First, you have to do this, justify the determinant. And you can see where I made lots of mistakes and I had to use a lot of whiteout because I read my 0 as a 9 and then I messed everything up. Then you have to do this, which is finding cofactors. And again, I read my 0 as a 9. That's where the whiteout was. So you have to do all of this calculation. And then you do this. And then that will finally get you to the inverse. So it's pretty much just as much work as we just did. It's the shortcut, but it's not really a shortcut. Now, the plus side is, so if I go back to this 2x2 where we did it with this method, you can do the 2x2 doing Gauss, the Gauss-Jordan elimination, and it's probably about the same amount of work as this was. But there is a shortcut for the 2x2, which is quicker, assuming you don't make any math errors. And so there's this formula here. So first you need to find what is called the determinant, which again is in the section after this stuff about inverses. And that's you multiply your diagonals and then subtract them, and you have to do it in a certain order. And then you take your matrix and you're going to flip-flop one diagonal, basically reverse the order. So if I highlight which ones get reversed, this diagonal gets reversed. You flip-flop their places. The other diagonal, the signs become negative. So it changes signs, but does not flip out or flip-flop. And then you divide it by the determinant, and that's your inverse. And that is the shortcut, but you still have to make sure you put everything in the right spot. So basically what I'm going to say to you after you've gone through all this on how to find the inverse is, 1, if you are going to solve by finding inverses, don't do it for a 3x3 or higher, unless you use technology. Because you saw how many steps that took just to get the inverse. And that's just the inverse part, not the solving part. The solving part, you then have to multiply your matrices together, which then can have more errors. So I don't recommend it for 3x3s. If you do 3x3, use technology. You could do it for a 2x2. Just be very careful when you're creating your inverse that you have everything in the right spot. And I would use this shortcut here to find the inverse versus maybe doing the row reduction or the other methods that we did for a 2x2. But just be very careful that you're putting everything in the right spot because it's very easy to mix it up. So that would be my advice. Would you say most errors happen when formatting the matrices or actually doing the math? Both. The errors that I've made errors writing down my matrices by writing down the wrong number and putting it in the wrong spot. And I made errors actually doing the arithmetic. Just like you've got just adding, subtracting, messing up sign errors, doing my multiplication wrong. I think errors in both parts are equally likely. So matrices are something that we do it by hand this week so that you learn what's going on. But anytime you have to use it going forward, like in your future courses, don't do it by hand. Use technology because it's just one of those things where so many errors can occur. Yeah, and every time a human is involved, there are errors. And it's just that so, I mean, from the one hand, it seems easier because you don't have variables, but then it's so easy to make mistakes with your signs and multiplication, all that kind of stuff. So, for your homework for this week, and I'm going to pull up the announcement that I sent out yesterday. I'm okay with you using technology on the homework, but you do have to show me, like, first give me your system, put the system in the form, and then tell me what you did using technology. Like if you're using the row, the RREF command, write that down and then give me the result. So if you're going to use technology on the homework, which I'm okay with, you still have to tell me what you were doing, what you started with and what you ended with. If you're going to use inverses, you need to show me what you started with to get the inverse, what the actual inverse was. Then if you're going to do the matrix multiplication of that inverse times your B, you have to write out what you're multiplying and then give me the result. So you can't just give the answer without showing the starting point. But the inside steps you're allowed to skip with technology just because I know that it takes a while. But I do encourage you when you've got a 2x2 like this, it's not so bad to do it by hand. I do encourage you to do it by hand, at least to kind of learn the process. So that is sort of my advice for doing all of this. And I have lots of websites here that you can use to check your, if you don't want to do Octave or Desmos, there's a whole bunch of other ones here. But it's so easy to make mistakes. So this is my advice to you. Just make sure you're showing enough work so that I know what you started with, what you entered in, what commands you did. Because if you only give me the inverse and you don't give me like what method you use, like did you use the row reduced method or did you just use the command inverse on the calculator, like whichever one, I kind of need to see what you're doing there. So, are there any questions? Did going through this process for the row reduction that we did, does that help organizing your row reduction? Where you tend to make errors with mistakes and stuff. Is that helpful? Okay. Well, I know that I went past an hour here. Doing those 3x3s really takes a long time. So, but I feel like it's important to kind of show you how to do that because that way you kind of understand it. But um, lots of help for you. Good, good, good. If you are doing the homework and if you're doing it by hand and you can't find your error, you are welcome to send me your work and I can look at what you're doing and try to find your error. But sometimes you need somebody else to look at it and then be like, oh, you just multiplied wrong here or something like that. So if you do run into that, you're welcome to show me what you have and I can try to help.